Okay, hello, welcome to my channel. My name is Lilo and in this video we want to evaluate the limit of 1 over n to the third power plus 4 over n to the third power plus 9 over n to the third power and so on and so forth up to n minus 1 squared divided by n to the third power plus 1 over n. Good. So you notice at the bottom we have n to the third powers at the bottom, except that for the last term, but for the numerators we have perfect squares. So this is 1, which is something as 1 squared, 4 is 2 squared, 9 is 3 squared, and so on and so forth. So maybe to make everything to look nice, I'd like to multiply the numerator and denominator of the last term by n squared. So this is n squared, and then this is n squared as well. The reason why I'm doing that is, you notice that when we multiply numerator by n squared times 1 becomes n squared, which agrees with the squares, okay, that we have at the top. Then the bottom, n squared times n will be n to the third power, which agrees with the bottom. So by doing that, I can easily factor out the 1 over n to the third power at the bottom. Okay, by so doing, we will factor out 1 over n to the third power. We'll be left with 1 over n to the third power. Then in the bracket, okay, this bracket here will be left with 1 plus here will be left with 4. But 4 is the same thing as 2 squared. Like I said, here will be left with 9 after factoring 1 over n to the third power. But 9 is the same thing as 3 squared, and so on and so forth. Okay, till we get to this term, which will carry only the numerator, which is n minus 1 squared, and then plus n squared, because n squared times 1 is n squared. Okay, so that's what we have. Okay, now before I proceed, let me recall a very nice property, that when we have the sum of the first n squares, okay, that the property goes this way. So when we have 1 squared plus 2 squared plus 3 squared and so on and so forth up to n squared, where n is some positive integer, okay, this is the same thing as n into n plus 1 into 2n plus 1 divided by 6. Good. So this is the property we're going to make use of. It's like a tool. Okay, it's very, very important. So since this is the sum of squares is what we have in here, we're just going to replace this with this fraction right here. That means that the limit is going to become the limit, okay, as n tends to infinity of, so you notice what we have, 1 over n to the third power is outside. Good. But for the inside, we'll replace it with what we just discussed, and that is going to give us, well, that will be the sum, that will become n into n plus 1 into 2n plus 1. Okay, I know here I'm using like the same n's in the example and in the what we're actually doing, but it's okay. So this is divided by 6. Okay, so that's what we have there, and then we close that right there. Good. But some things will cancel, but before then, maybe let's just put this 6 out front. So this becomes this 6, or the denominator, let me put it out like this, like 1 over 6. So that becomes the limit, okay, as n tends to infinity of, now notice that this n will cancel out with one of these n's, leaving us with n squared. Good. And that means we just have to multiply this bracket, then the n squared is at the bottom waiting for us. That's the n squared right there. Then we multiply that, we expand these two brackets. So when we expand the two brackets to n times n squared, that will be 2n squared. So we have n times 1, that is n, plus 1 times 2n, that brings about 3n altogether. Then plus 1 times 1, which is plus 1, because 1 times 1 is just 1. Great. Okay, so that's what we have. So maybe let's move up here. So this becomes, well, let's see. That is the limit. Okay, 1 over 6 times the limit. So let me put the 1 over 6 out here. Times this limit, that's the limit as n tends to infinity of, well, let's we'll distribute this 1 over n to everybody inside. When we do that, you notice that some of them will cancel out, like n squared will cancel out with this n squared, n will cancel out with one of the n's, and then 1, this is just 1, so 1 will not cancel out with anything. So inside the limit we're going to have 2, okay, plus 3 over n, okay, plus 1 over n squared by the reason of cancellation. So you notice that the 2n squared, the n squared with the 2 will cancel out with that, so we'll be left with that. That means this is going to be what, the limit 1 over 6 times this limit. But well, as n tends to infinity, in other words, the denominator gets larger. 3 over n breaks down to 0. Similarly, 1 over n squared also approaches 0 as the denominator gets larger. It's like saying split a particular number of things into a certain number of places. Then the number of places gets increasingly large. That is without bounds. So the number of the quantity for each place will be so small. So each of these will get to 0. So that 2 plus 0 plus 0 is just 2. Then we have 1 over 6 times 2. That leaves us with 1 over 3, which is the answer to that. So the limit here is 1 over 3. But while this may be confusing at the start, some people may go ahead to say, well, using what I just explained here, that as the denominator gets increasingly large, the thing will be breaking down to 0. So you say 1 over n to the third power will approach 0. 4 over that will also approach 0. This will also approach 0, and so on and so forth. Okay, so that everything becomes everything approaches 0, so that the whole thing sums up to 0. But that's not true. That's not true, because when you're adding infinitely many things, you know, n is approaching infinity. In other words, the number of terms approaches infinity. No matter, this right here is not really 0. So this is 1 over n to the third power is approaching 0. It's not actually 0. So you're just approaching 0. So it's a problem of our limits. Okay, so that's 1 over n. So that's 0 plus. That is approaching 0 from the right. This is approaching 0 from the right, and so on and so forth. So these are not really zeros. They are like very small positive numbers that you can neglect when it comes to addition. But when you sum them up, infinitely many of them, that is from here to here, as n approaches infinity, and it becomes significant. The sum becomes significant, and that's what we see right here. So yeah, this right here is the answer, and this is the tool we made use of. Okay, thanks for watching. I hope you enjoyed the video. Please follow my page, subscribe to my channel, and we'll continue for my next video.